and let's go ahead
Perfect.
and get
Thank
this
you.
kicked off. This is Stephen Bavington. He is a sales engineer, and he is going to be talking about ICS protection.
Good morning, everybody. I'm transmitting from a secondary location this morning on account of the hurricane that came through. So I'm going to kill my video while we have the presentation just to save bandwidth. And please put any questions in the chat. Here we go. Oops. All right, so if everyone can hear me, I'm going to talk about ICS protection, and we're going to focus primarily or particularly on legacy equipment in the network. Let's see. So we're in the middle of the fourth industrial revolution, and this is just a pictograph. Steam, powered by belt-driven equipment. These are very dangerous places to work. They had fatalities and lots of injuries, but we learned how to manufacture things in an automated way. After that, Henry Ford invented the idea of using electricity for assembly lines. It drove the price of cars down where everybody could afford them. It was a very big step in progress, and this spawned all kinds of industrial operations around the world. Then in the 90s, we started using computers to build things. These are hard valves. Computers build them very well and quickly and accurately. And then once we had computers doing things, then we obviously had to network them. And we have sort of a past generation. Lots of new stuff happening, but there's a lot of old legacy equipment out there that's vulnerable. And the business is sort of trying to force the factory to be connected to the internet to speed things up. And it's exposing all this equipment to all sorts of vulnerabilities. And we're going to talk about ways you can deal with that. This is a list of the top 10 threats that these ICS factories have: an infiltration, malware, malware infection, and which ones are on the rise and which ones are really on the rise. Human error and sabotage. Incidentally, it's emerging that a large portion of the attacks are accidental. People bringing infection and whatnot into the network without really understanding that they're doing that. Social engineering and phishing is sort of going down primarily because people are being better educated in not to click on emails, etc., and some physical blocking in the internet to the factory that we're going to talk about. DDoS attacks are really on the rise. Control components connected to the network, sort of in the medium, they can infect other machines, and we're going to talk about how to mitigate that. Intrusion by remote access, still steady, is always a problem. Technical malfunctions are dropping. Things are getting more reliable. People are learning how to do redundancy and whatnot. And compromising of smartphones in the production environment. A lot of factories are asking people to leave their cell phones in their lockers and not bring them out onto the factory floor. So we want to talk a little bit about how do you protect the factory. There's a conventional wisdom that firewalls are going to do it in, the way we protect the IT network. We put in a firewall or an IPS. When we plant endpoint software on those devices and we protect them. And a lot of places are still trying to adhere to this paradigm, which we believe is not all that effective. Here's another diagram of even more firewalls in different levels of the factory. These are generally the conventional wisdom today. So let's talk a little bit about how you would protect the factory. So obviously, in this case, they've just connected a wire from the factory to the office, which is not ideal. There's no factory protection specific yet. It's vulnerable to weak devices within the IT network. So if somebody compromises one of those devices, for example, the printer, they could easily access the rest of the network. And then you have, outside devices coming in and then gaining permission to the network, and they too can scan the entire network and find their way into planting malicious code, either accidentally or on purpose. So the next phase is to throw in an IPS and a new firewall and block the traffic between the factory as you desire it and the factory in the office as needed. Um, Incidentally, we're finding out that there's a lot of operations that have a factory where the automation is contracted out to different people that run the equipment down below. And some of our customers are asking us to protect the IT network from the factory instead of the other way around. So you're still vulnerable to rogue devices, as I said. If somebody brings a laptop into the factory, they may intentionally or accidentally infect equipment within, have access to everything. And then everybody remembers the infamous USB stick. This is still a large source of accidental and intentional infections within the network. So we believe that a better approach would be purpose-built appliances, either a firewall or an IoT specific. So these are purpose-built devices that are built to protect or to mitigate the kinds of attacks that these things would experience, as well as being able to whitelist and blacklist them so that we can even control which devices can talk to which devices at a very granular level. So you place these things as close as possible to the devices you want to protect, and then you program them to protect that device and to protect anything else from that device, which we will talk about a little bit in a little bit. And you continue to do this across the entire network. They're inexpensive devices that are programmable and purpose-built for the IT network. Another layer of protection is the ability to turn the computers that live in this network into what I would call a kiosk, or lock them down so they can't be turned to any other purpose. They can only be used for the purpose they were intended, and we have the ability to let our software learn what is running and what's not, what's supposed to be running and what's not, and lock them down so you can't plug in a USB device to it that's not allowed, and you can't log into it and check your email. It can only do the operations that it's intended for. And then the last step is to put in what we call the OT Defense Network. This is a device that connects all of these appliances together so you can manage them with more global visibility. You get virtual patching, and virtual patching is the ability for these devices to be aware of known attacks, attack vectors, and block those, which is built in them intrinsically. So any CVE or other attack that is well defined will be injected into these devices on a regular basis, so that new attacks will be mitigated automatically. And we have ICS blacklisting and whitelisting. This is the ability of these devices to understand the protocols that your customers' assets would use, and the commands within those protocols, and whitelists and blacklists the things that we don't want them to be exposed to. So if one of those robots at the bottom only needed 14 or 15 of the 128 commands in Modbus, we can make sure that it only sees the ones that it's made for, and nobody can try to do anything different with them. The other thing that it allows is we can prevent that device from talking to any other device in the network. So if it ever became compromised, we can isolate that compromise to specific devices. One of the other things that customers appear to be looking for is OT network visibility. Many of these devices in the factory don't have the ability, or were never built to have the ability, to tell you what kind of a traffic they see and how much of each. And this device will identify the asset, keep track of the traffic that's going to and from each asset, and you can see that visibly. So network visibility in the OT networks is suddenly available. They're very easy to manage. Every one of these devices has its own web interface, very, very intuitive, very easy to use, and so does the defense console. Network segmentation is an important part of the development of the OT network and creating networks with those devices, the IoT firewall, to allow them to make sure that devices that don't need to speak to each other are actually on separate networks. Um, individual IPS protection is a valuable piece of this. As contrasted with the perimeter strategy, we can not only protect that device from intrusion from outside, but also from intrusion from inside the factory, and we can protect the rest of the factory from it by configuring these properly. So this is the kind of function you would want one of these devices to use. First of all, you need identification of the asset. You want to find out if it's a PLC or an HMI or any of the other devices in the network. Devices for this purpose should be able to identify these devices and make sure we understand what they are. Secondly, we want to make sure that the protocols and the functions within those protocols are identified so that we can now write filters to them and be able to block or whitelist or blacklist whichever of those devices we would like. Intrusion prevention and the virtual patching is a valuable component. We would like to be able to take any ICSA or CIVE that's known or published and make sure that these devices are armed to understand them and make sure that our assets are protected from any kind of attack. Machine learning is a mechanism by which these devices can learn what's normal, what's not normal, and when anything new happens, for instance, an attempted DDoS attack, it can actually block those attacks. And this is all done on one pass using what's called deep packet inspection, where we take each packet in and tear it down to layer 7 and find out exactly what's in it and compare that with the filters and the intrusion prevention and virtual patching that we have in configuration and decide whether we want to pass that packet to the asset. And we can do that per asset. So we don't have to have, we get much more granular protection than a perimeter strategy would give you. So I know this is a bit of an eye chart. We can make sure everybody gets a hold of this afterwards, but these are protocols which these devices do deep packet inspection on and make sure that they compare those things, as I said earlier, with the filters we have. So we also have a list of IT protocols, so we can prevent NTP, RDP, which is a big one, and SSL traffic from getting to these devices if they're not compatible with it or if they're exposed to vulnerabilities in these protocols. So the discrete device gives us network visibility. That's kind of a big point. As I said earlier, a lot of these networks in operation today, the operators don't have any idea what kind of traffic is going to these devices. They're sort of guessing. You know, they have, if you're using a perimeter strategy, then you have to allow a lot of things in that you may not want to get to any, you may have to go to one device, but you really don't want to go into another device. So operators have devised a number of really elaborate VLAN strategies with ACLs in the firewall to try and mitigate traffic that they don't want going to these devices. Protocol filtering and whitelisting control is really important because some devices may be vulnerable intentionally or accidentally to some attack, like some operating systems are vulnerable to ping. If you ping them too hard, they'll crash. But you want to be able to ping some others because some of their management protocol requires it. So it's a very difficult, this is a very difficult problem to solve with a perimeter strategy. Virtual patching is huge. You don't have to try and write filters yourself for some kinds of attacks. We're going to provide you with those and make sure that they wind up. And obviously, they're going to have some proprietary OS inside. This is an example of the kind of specification that you'd want for a device to be deployed that would protect your devices within the network. Some of the functions that you want, going over this from a different way of looking at it, is the virtual patching, which is a dual mode in monitoring or in blocking mode that can allow for identification and blocking of known attacks. The factory operator generally isn't an IT superhero, so he would definitely need to be able to manage this device. So we made it as simple as possible. Is there a question?
There is indeed. From Sid, we have the question, any thoughts on securing networked medical devices?
Of course, yes. We can go into that in some detail later on if you like, but we have a best practice suite for medical devices, for power and gas, and for manufacturing, of course. All kinds of the nature of this device is that those medical devices are vulnerable to the same protocols, and from the box's perspective, it wouldn't care whether it was a robot in a car factory or a medical device. But yes, we have some detailed strategies. I can break away from this presentation and go into best practice for medical if we like, if we have time. Does that answer the question? I hope. Sid?
Yeah, it does. We just have a lot of
Okay, good.
medical devices that are especially legacy equipment that it's a real
Yeah.
problem.
Yeah, so if it's a piece of hardware device with a proprietary protocol, you would use one of these devices, and you can program it to be the whitelist and blacklist and do virtual patching and make sure it only talks to the things it's supposed to. If it's a Windows device, you can use that lockdown, what's called safe lock, and lock them down to a kiosk so nothing else can ever be done with them. Or you can do both.
Is there any scaled versions of these? Because I know a lot of these, especially medical practices, are very price conscious.
Mm-hmm. Yeah, there's a device that just came out, which it's sort of out of scope for this presentation, but I just got the announcement today. But it's a high density rack mounted, 48 of these in one shelf. Honestly, we'd have to put you in touch with the sales guy to get pricing on that.
Okay, thanks.
But yes, these are very inexpensive to begin with. You'll be pretty shocked Lou Kowalski can probably tell you a little bit about the pricing, but they're very inexpensive.
Any order of magnitude as far as the expense?
What do you mean by order of magnitude?
Like, is it it's in the range of so many dollars?
It would be more than that. If you want to reach out, go to the booth later on and reach out with Lou Kowalski, and he can have a talk with you, discussion with you about the pricing of the different devices.
Perfect.
If that's all right?
Yeah.
All right. Moving along. Any other questions? Okay. So these devices are purpose-built to live in the environment of the factory. You don't need to have, climate controlled at 70 degrees and some humidity. They'll work from, 40 below to 75 C, and you can put them just about anywhere where your equipment is. And the idea is that we want to get them as close to this equipment as possible because we want this to protect each device to protect the equipment it's assigned to protect, or groups. As I said, they do deep packet inspection at 200 megabits a second. So the architecture would all depend on, the differential and what kind of filters you need and how much traffic there's going to be. And anybody who works in ICS will tell you that individual traffic on one device is fairly small. So this is the lockdown protection for Windows devices that are legacy. We want to be able to take the devices and make sure that they're not vulnerable to things they're vulnerable to without our protection. We also want to make sure nobody can plug in a device that's not authorized, and we don't want anybody to run any software on it. We don't want anybody downloading a browser or putting some software in there in the factory. Once this is enabled, you can't. Only permitted USBs can be accessible, and we can do scanning on USB content on the way in to make sure that even if it was an authorized USB stick, we're going to scan it for vulnerabilities before we actually open it up to the OS. This is designed to keep the operation running. We have an operations lockdown, which means nobody's able to do anything that it isn't programmed to do at the beginning. We have a data lockdown, which means the data is specified in the lockdown is not compromised or changed. We make sure we have a USB lockdown so that USB devices that are not authorized cannot uh, be exposed to the machine. And we have a configuration lockdown, so configuration files like the ini file or any of the other configuration files in that area are not allowed to be changed. And this works by you deploy the software, you clean up the system. In other words, make sure you know that it's running the way it's supposed to be running and nothing else is running on it that you don't want, and you turn on lockdown. And then the whitelist baseline is auto-created, and the system is locked down from this point forward. It can't, you put it back into operation. From this point forward, you can't do anything to this machine that wasn't running before you locked it down. In the maintenance mode, you just stop operations. You put the thing in what's called an update mode, so it allows you to change whatever it is, do your patching or add new software, or have some new users or whatever it is you would like to do to this device, and then you lock it down again, and it's back to being a kiosk, if that's the right definition. The next level of protection is this for air gap networks. Is this called a USB scanner? You plug this in to your device and it can scan it for any number of vulnerabilities. So the strategy here would be using this kind of a device to inspect equipment on the way in. Not only your production equipment, but any new stuff, any new stuff that's come from your supplier, you can scan it before it goes on the shelf into storage, or people coming in with laptops or whatever else to work in your network as authorized, and make sure that they don't do anything wrong to your network by accident. So do you want to go into the medical strategy? Just give me 1 second. I hadn't planned on doing that, but I will go and take care of that right now. We'll show you some of the medical. Just pardon me for one moment. Since I had that question. I'm sorry, I had kind of a scary morning this morning with rushing around. So this is best practice for healthcare, Sid. We're going to talk about the environment of the medical center. It has these devices which you probably recognize better than I do, or they're in the network. Some of them are on VLAN, some of them are not. Some of them are on Wi-Fi, some of them are not. We have some questions.
27,900. 27,900.
Hello? All right, I'll continue.
Sorry about that, Stephen. Go ahead. I'm unmuting the chat so that they can hop in while you're speaking about the question that was asked earlier.
Okay, cool. Any questions, welcome. So this is generally what we see as the environment of the medical center. We got chats in the way. So we have the network configured in this manner, and all of these things are vulnerable not only to things that might get past the firewall, but to each other, right? And if we place our devices, so non-TX module have to stay on the Win 7 XP with no security updates, so that would be a good candidate for that lockdown software. And next. So how to protect all your endpoints, including the legacy ones, without impacting performances. So some of these devices just live on the wire and they do their job. They don't slow anything down. And how to remove malware from the machine is kind of important. How to have communication with traffic visibility under control. So we talked a little little bit earlier about might not be able to report what traffic they're seeing. How to avoid cases of carelessness resulting from misconfiguration. So there's a speaks to the kiosk lockdown scenario. We can make sure that you can't change anything, and if you really need to, you probably got to go find the administrator and get him to put that device in maintenance mode, you know, and if you protect these robots, you know, there are 4 or 5 of them connected to a switch, and you got to change one out. You don't have to go and configure that thing to protect itself. It's already protected by that IPS or firewall that traffic is filtered through. So what we want to do is secure the medical environment. So a phishing attack, CVE 150 or buffer control. That's kind of one use case. Top Windows 7 vulnerabilities that we protect against. All of these are fairly well documented out there, and the lockdown software plus the IPS and firewall would block these attacks with the virtual patching function. Windows 7 proposed. I'm not that familiar with what a modality is, so I apologize for that, but we do protect against the vulnerabilities for it. We can scan them with the portable security, and safe lock modality prevent the unexpected application from being executed. So as we said before, once that's in kiosk mode, we can't do it. If you place the IPS in front of a group of these devices, then they can't see the same attack. So you got a layered protection. And as I said before, you can choose which strategy you would like for which place, and have this layered protection scenario that keeps your traffic flowing without slowing anything down. Any questions here? I thought you'd have at least one question, Sid. So we've got a couple of customers that we've sold this to bundled with DDI, which is a completely different SOP that gets a sort of a level 5 east-west protection scenario. The attack type was local network access parameter changes in the hospital's network. We forced some of the GE anesthesia devices to modify the parameters without authorization. The concentration of oxygen, et cetera, to the medical folks would make a lot of sense, so we can prevent these sorts of attacks from happening. The proposed solution for immobile portable modality, we placed one edge IPS in front of each iMobile, high value target. We place one IPS between the modality switch and the router to provide APS protection. And we place an ODC, which is the management platform, so that you can see all of the devices you've placed in these other assets to protect them. And we place an edge fire on the side of the router to make sure that we can protect it from inbound threats. And that looks like this. So it's very similar to the previous scenario. So the idea being that just very modular. It's you can, if you want to build out another VLAN, you can go and build out another one and just throw on a new edge IPS or a new IPS and just add it to a group within the management platform, and it will have the same protection and configuration. So in this way, you can protect the portable units. As I said, they're made to go as close as possible to devices. So even though it's mobile, it just runs off the same battery as the cart, and provides excellent protection. So the virtual patching is really important to protect Windows 7 based modalities, because we're going to keep track of current and even past attacks and make sure that you're protected against them. HL7 protocol visibility. Some of these, well, as I said, this is a protocol protection. We can make sure if the HL7 is the protocol being used by your device, you can make sure that only HL7 commands are passed through, and you don't have to worry about some other kind of command that the machine may be vulnerable to from getting in. The system lockdown operation, data configuration, USB prevents anybody from walking up. It even has physical access to the machine from doing any damage to it, which is kind of new, right? This is a sort of it's been overlaid with some graphics, but we call a device, in this case, the firewall, a node. And that node would be responsible for protecting some number of assets on the other side of it. And what we have here is a list of assets, and we're also showing you what kind of traffic and what protocol that traffic was that that machine is exposed to. This visibility is a vehicle for how you would configure the device to, if you don't want it to be getting any others and you find out what they are, you can start blocking them at port level and make sure those communications aren't getting through any longer. And on the left, you see a list of each asset. So we're highlighting the one, but there could be multiple assets being protected by either one of these devices. As I said before, the limitation is a 200 megabits per second of deep packet inspection. And before anybody asks me, if you exceed that 200 megabits, it's a gigabit interface. It still passes the traffic that we just might miss identifying some kind of an attack if you oversubscribe it. You get granular control over popular medical and ICS protocols across the board. As I said before, the IPS and the firewall would not differentiate the CU ultrasound device from a robot in a factory necessarily. You just have to make sure the right protocols are being covered. It's a network device, so it does its work at that level. Question?
Yes, Sid dropped in the chat that he would like to see the last diagram. I don't know if you have that available to send to him or if they can come to you afterwards at your booth.
Which diagram was that, Sid? This one?
Before that, it was actually the first DICOM deployment. This is, no, that's not it.
That one?
I'll get with you afterwards.
Yeah, that's fine. You just track me down. I'll be able to have a private session with you at your leisure.
Perfect. Thanks. I appreciate it.
No problem. We were here. So actually, that's the end of that presentation. So I'm open to, we're finished kind of early, but I'm open to Q&A from here. And if you need me to go and find some other resources, I can do that. I have to apologize. I was a little bit rushed this morning, and I actually only expected to be doing a 30-minute presentation today.
What do you see as the biggest challenge people face when they're trying to deploy these kinds of solutions?
This is what I see as the biggest challenge right here. This is, I mean, a hospital would look something similar to this, and so would a tire plant or anything. Is that this network grew out of, like, first there was one PLC and there was a robot, and somebody sat in front of it and fed tape into it, or maybe a little bit more advanced than that. But then they came along with some cameras that started doing monitoring, and then there were some sensors, and they just built this network piecemeal, but they never took anything out. They never improved it, and they found themselves, as you know, with Windows 7 and Windows 98 and Windows 95 devices that are still legacy, that the infrastructure they control is proprietary to them, and they're not going to replace it. So if you could maintain an air gap environment for those devices, that would be kind of okay until the resistors all the medical profession, the business is sort of demanding that you have access to the internet. Doctors want to be able to come in and program these devices, and I mean, and you know, we see it all over the place. This pressure on connecting to the internet is causing all kinds of grief. What I have seen to date is that that firewall that's inside or between the factory and the office is being utilized in a really crazy way. They build a VLAN for each device down below, and then they write ACLs, firewall control rules, to make sure that device A can't talk to device B, even if they're in like almost on the same switch. And that's hard to do. It works pretty well, but what happens is if you have change management, you can make a mistake in that list. Anybody that's dealt with a big access control list will tell you that if you make one mistake with that thing, you can shut half the factory down. So, and also, and this is all in an effort to keep devices from talking to each other or talking outside on the internet or whatever the scenario is. And it's time consuming and dangerous. The ability to have a very simple and inexpensive device sit right up against the asset you're trying to protect is huge. That's what I see as the biggest problem. Apart from the fact that we got legacy devices we can't get rid of that should have been gone 10 years ago. Right.
What are the challenges that people deal with when they are actually implementing a solution like yours?
That's a great question. I probably should have covered that. So we have 3 modes of connection with all of these devices. They can be connected in a sort of a port mirroring mode, where you can attach them to a switch and just send the traffic to them, so you can have an idea what's going, you know, a periscope to what's going on out there. Secondly, you put them in line, which may be one of the big problems. People are very touchy about putting anything in line that may be deemed as a single point of failure. But they can be inserted in line and put in monitor mode, so that no matter what configuration you give them, you tell it you want to block ping. Well, it'll tell you somebody's trying to ping that machine and I should be blocking it, but you have me in monitor mode, so I can't. And we knocked that challenge down by allowing you to do it in monitor mode for some amount of time. In fact, have customers that are running these things in monitor mode in different places in the network for a month or more, until they're really, really cozy about it. It's telling us to do the right things, and then they'll flip it on to blocking mode. The other thing is, I think people are very reluctant to, you know, it's a pretty scary environment, but I've been lucky getting what I want out of it to date, doing the way I'm doing it, and I really don't want to change. So the reluctance to change may be another big problem that we see. We believe that this change is inevitable, and we can help you make it real easy. People take these devices out of the box and they're using them in 15 minutes, and then they want more. I mean, they're so simple to work. It's not funny. Does that help, Sid?
Yes, absolutely. Thank you.
You're welcome. Anyone else have anything they need? I'm sure Lou has a question. Yeah, so I think the last thing that I have, Brittany made me promise to ask you guys to go to the booth and join the raffle. Oh, sorry. Visit the trend booth, schedule a meeting or cloud health check, and wow, I'm going to go to the booth. There's a Apple Watch. Yeah, anybody on the call, if you want to have a more in-depth discussion about any particulars or any detail that you may have, please go and see Lou, get him to track me down or track me down yourself, and I'll be happy to do a private session with anyone in detail. POCs are easy to set up. We can ship out some equipment for trial at any time. And that's just about all I had for today.